In today's video, we will be going over how to do inverse trigonometry. To start off, we are going to look at the different types of trigonomic rules and regulations. So to start off, we are going to look at the domain and range restrictions for sine inverse, cosine inverse, and tan inverse. So let's start off with sine. So the sine inverse function looks something like this, where you have y equals sine to the power of -1, or sine inverse of x. Now, for the domain, we have a domain restriction of -1 is less than or equal to x, which is less than or equal to 1. We also have a range restriction. The range restriction for sine inverse is -pi/2 is less than or equal to y, which is less than or equal to pi/2. Now, let's see how these restrictions look on the unit circle. So right here, we have the unit circle. And as we said, our range restriction is -pi/2 is less than or equal to y, which is less than or equal to pi/2. Well, if we look at our unit circle, we can see pi/2 right up here. So we can go up pi/2 from 0, or we can go down pi/2 from 0. So if you look at this, pi/2 goes 90 degrees here, or 90 degrees here. That means that we can have an answer on this side of the unit circle for sine inverse, meaning that we can just basically eliminate this left side, meaning that all our answers for any of the practice problems we do or the problems you guys do in your homework will be from this right side if it is a sine inverse equation. Next, let's go ahead and take a look at a cosine equation. So for cosine, we have y equals cosine inverse of x. Then our domain is basically going to be -1 is less than or equal to x, which is less than or equal to 1. As you can see, they're both the same. The domain is the same for sine inverse and cosine inverse, but the changes come when looking at the range, because the range of a cosine inverse is 0 is less than or equal to y, which is less than or equal to pi. Now if we look at the unit circle for cosine, we establish that there's a range limitation of 0 is less than or equal to y, which is less than or equal to pi. So we can see that pi is right here. So now, if 0 is right here, we can go from 0 to pi, but we can't go anywhere else. If you remember, for sine, we could go from positive pi/2 to negative pi/2. Because we're adding pi/2 here, and we're subtracting pi/2 here. But since here we start at 0, and we can only go to pi, we can basically eliminate this lower portion, meaning that any answer with a cosine inverse is going to have an answer from this top part of the unit circle. Now, let's go ahead and look at a tan function. So for tan, we will be using the color yellow, and tan inverse looks something like this. The domain for tan is, however, a little different than both the sine inverse and cosine inverse, because the domain for tan is x is a function of all real numbers. The range for our tan function is -pi/2 is less than y, which is less than pi/2. You might be thinking this looks really similar to our range for our sine, but you can see that this does not have the or equal to, meaning that in our range, we don't include these two values. So if we are going to look at a tan inverse, we are going to be having a positive value and a negative value of pi/2. So we can't have anything like this, we can't have anything here, can't have anything here, and we can't have this value. Meaning we can have 5pi/3, 7pi/4, 11pi/6, 0, pi/6, pi/4, and pi/3. Anything else would be out of the range for a tan inverse function. Now, we can also look at the different types of ways that it can be written. So, a function is for sine, in this example, if it says sine of angle, meaning theta, or 40 degrees, 50 degrees, whatever the angle might be, this will be equal to your answer. Or, if we have sine inverse, so inverse sine, it will have our answer in our parentheses, and then it would be equal to our angle or our theta. So let's go ahead and start doing some practice problems. So in our first practice problem, we are going to start out with cosine. And again, for cosine, we did use orange, so let's use orange down here. So our first practice problem, we're going to have cosine inverse, so inverse cosine of -1. Now, if you guys look of our base formula, or our base equation, it's going to be cosine or sine inverse. We're going to have our answer right here, and then we're solving for the angle or the radian. In this case, we're looking at the radian. So now let's head back to our unit circle for cosine and find where our cosine value is -1. So now, if we look at this unit circle, let's just try to find where cosine value is -1. Well, we do know that cosine is equal to our x values and that sine, and we also know that sine is equal to our y values. Now that we are looking for a cosine value, let's just find where x value is -1. So we can see that at pi, it is -1 for x value. So, and that -1 is within our range because we can go from 0 to pi. So since we are in our range, we can say that at pi radians is where our answer will be, or that would be our angle. In this scenario, we have radians, so our answer for number 1 is pi radians. Now let's go ahead and do another practice problem that is a little more complex. So in this practice problem, we have sine inverse of cosine of pi over 3. So now there are some steps. So now we need to look at this. Does it fit this equation or this equation? I think that it actually fits our first equation because sine of our angle, in this scenario we're given a radian, equals our answer. So we are looking for the answer in this scenario. So here we're going to find the cosine value when on our unit circle we have a radian value of pi over 3. Now if we head back to our cosine unit circle and we look at pi over 3, we can see it's right up here. And we look for the cosine value and we establish that cosine is our x values. So our x value at pi over 3 is 1 over 2. So at 1 over 2, so at pi over 3, our x value is 1 over 2. That is our cosine value. So now, since we are going with this equation, because that's what our given problem fits, we are going to say that this parenthesis equals 1 over 2. And now we're looking for the sine inverse. We're looking for the sine inverse of 1 over 2. Now again, we can head back to our base equations. So if we look, when sine inverse is there, in the parentheses we have our answer, meaning that we have to look at the unit circle and say, hey, when is sine 1/2? And then we'll get our answer. So now that we have that, let's go head back to our sine unit circle. So in our sine unit circle, we need to look for our y value because we said our y value is our sine value, where the y value is 1/2. Well, we can see that our 1/2 value is at 5 pi over 6 right here and pi over 6. Well, we can see that 5 pi over 6 is in our no-go zone. Well, now we know that the parentheses equal 1/2. And we're looking for sine inverse of 1/2. Now again, if we look back at our equations, we know that when we have sine inverse, in the parentheses we actually have our answer, and we're just solving for the angle. Meaning that we have to look for, on the unit circle, that when does sine equal 1/2. Now let's head back to the unit circle and look for sine when it equals 1/2. Oh my goodness. Now let's head back to the sine unit circle and see that where our sine value is 1/2. So if we head back up, we established that our sine value is our y value. So now, if we look for our y value with the value of 1/2, we can see that we have a value of 1/2 at 5 pi over 6 and at pi over 6. Well, we already established that our range restricts this part of the circle, meaning that our answer cannot be 5 pi over 6. It has to be the other value, which is pi over 6, and it has a y value or a sine value of 1/2, meaning that the final answer to our problem, or number 2, is pi over 6. Now, we have established how to do a sine inverse, a regular sine angle, and now we're going to do one last problem, which actually involves the Pythagorean theorem. In this last problem, we're going to be given cosine of sine inverse of x over the restriction for 0 is less than or equal to y, which is less than or equal to pi. Now, we need to start out by saying, hey, what do we need to do first? Well, we can basically go back to our base equations. I suggest that in your notes, you guys write these two equations down as they're really beneficial. Also, throughout the video, or whenever you get a chance, get a unit circle, mark out the restrictions for the range, and make sure you guys have this with you. So we have this equation, sine inverse of x. If we go back to our base equations, we know that when we have an inverse, a parentheses is our answer, and it equals our angle. So since our angle is outside and we don't know it yet, we are now looking for this, which is x, which is our answer. So now, what is sine? Well, in the top right corner of the video, you'll see a small pop-up which goes over all the types of trig functions. Well, sine is opposite over hypotenuse, and we know cosine is adjacent over hypotenuse. Well, now what we can do is basically do Pythagorean theorem, where in this we can draw a triangle, and we know that sine inverse of x, which is our answer, equals our angle, and let's call our angle theta. So if we know it equals theta, well, we can basically rearrange. Because if we look at our base, if we switch these two, it'll make it a regular sine, and we can then solve for our angle. So we can go back down to our equation, we can say, hey, let's just switch it up. So we have sine, regular sine, not inverse, of theta equals x. Well, you can see that only things we changed are we swapped the positions of these, our angle and our answer, and then we made it a regular sine. Now, what we need to do is see that when our theta, when we're looking at the opposite over hypotenuse of our theta, so the sine, which is the opposite over hypotenuse of our theta or our angle, it equals x. Any number by itself is just that number over 1, right? So we can assume that our hypotenuse is 1 and our opposite value is equal to x. Now, so we can place our theta or our angle value right here. Let's just do this in white so it's a little easier to see. Well, now, what we can do is basically just do basic sine. So we have x right here, and we have a hypotenuse of 1, because this is the opposite, this is the hypotenuse, and this bottom part is the adjacent value. Well, we just said that adjacent over hypotenuse is our cosine, and we'll get back to that in a bit. Now, we have our opposite value is x, and our hypotenuse is 1. Well, now, we need to see that what our adjacent value is, because that's what we're primarily solving for at the end. So now, we are going to go ahead and do Pythagorean theorem. Pythagorean theorem, if you don't know, is a squared plus b squared equals c squared. And it is used in right triangles. This is our right triangle. Now, we have a value. This is going to be our a value. our b value and our c value. Or you could call this the a value, this the b value, and that's the c value. The hypotenuse is the c value. Anyways, we know that our a value is x when we're squaring it. We don't know our b value, so we can just say b squared. And that equals c squared. And we said c equals 1 here because our hypotenuse is 1. So we have 1 squared. Well, now, remember, our objective is to solve for b since it's our adjacent and we need it when getting our cosine. Now what we'll do is isolate the b value. So to isolate the b value, we're going to subtract x squared from both sides of this equation. And now we are left with b squared on the left side, and it equals 1 squared minus x squared. B squared equals 1 squared is just 1 minus x squared. Now we can take the square root of both sides, and we get b equals the square root of 1 minus x squared. And that is going to be our b value, which is our adjacent value. So now that we have that, so we have, what did we get? We got 1 minus x squared, and we take the square root of that. So we get the square root of 1 minus x squared is our adjacent value. Well, now we're just finding the cosine of this triangle right here. And we just established that cosine is adjacent over hypotenuse, right? So now adjacent, which is the 1 minus x squared, because we're looking at the adjacent to this angle. So the thing right next to it, or the side length right next to it, and obviously it's not the hypotenuse because that's the hypotenuse. And then that is over our hypotenuse, and we said our hypotenuse is 1. This basically simplifies down to square root of 1 minus x squared, because anything over 1 is just itself. So in my final answer, I would write that the cosine of sine inverse of x equals the square root of 1 minus x squared. And this is the final answer to the problem cosine of sine inverse of x. And the final answer is 1 minus x squared. I hope this video helped, and if you believe it did, please consider to like and subscribe. And remember to hit the bell notification icon in order to get updates for my future videos. And please remember to give future video recommendations in the comments. Thank you.